Good day, this is Mr. Caslin. We're continuing with pre-calculus. Let's do some trigonometric functions. Here's an example problem that you've given on your homework. We are given the sine of theta is equal to negative 5 over 13. Now notice we're not necessarily dealing with a 45, 45, 90 or a 30, 60, 90 triangle in this case. We're just given a fraction that represents the opposite and hypotenuse of a triangle. And we're told that this angle theta, this reference angle, is in the third quadrant. So if you remember from your Algebra 1, we always had the quadrant with the positive, positive. That was quadrant 1. We went counterclockwise, so we called this quadrant 2. Continuing counterclockwise, this was quadrant 3. And to finish it off, this was quadrant 4. So this helps us keep track of the signs of our sine and cosine. For example, we know that this point on this triangle, you'd have to go negative x, negative y. So you know that all the points in this quadrant 3 are negative, negative. So you also know that the cosine and the sine are going to be negative in this quadrant also. Alright, so what we need to do is figure out what our other trigonometric functions are going to be, our cosine of theta, tangent theta, etc. So the key is just setting up this triangle correctly. This is your reference angle theta. The reference angle always is drawn from your x-axis. Okay, we know that sine is opposite over hypotenuse from your SOHCAHTOA. So in this case, opposite is negative 5. And our hypotenuse in this case is 13. So we have a right triangle. We know two sides of our right triangle. We need to find the third side. Okay, we're going to use our Pythagorean theorem. I'm not going to go through all those calculations, but your Pythagorean theorem, a squared plus b squared is equal to c squared. So when they give you the hypotenuse, you have to do c squared minus a squared is equal to b squared, and you're going to find out that this third side is equal to 12. Basically 169 minus 25 is equal to 144. You have to take the square root of 144, and that gives you 12. Okay, so this triangle is the key to the rest of the problem. Now remember, this is third quadrant, so it's going to be negative 12, negative 5. And the hypotenuse will always be positive. Okay, so now basically it's just filling in all of your trig functions. We know that sine is, here let me we'll draw these in blue. You've got your opposite over your hypotenuse. We know that cosine is adjacent over hypotenuse. And we know our tangent is opposite over adjacent. Now our trig identities tells us that the sine of theta is the inverse of cosecant of theta. So inverse just means flip the fraction. So we have hypotenuse over opposite. The secant is the inverse of the cosine. Hypotenuse over adjacent. And our cotangent is opposite. Or better word is inverse of the tangent itself. Inverse or reciprocal. Okay, so that's going to be adjacent over opposite. Okay, so now it's a matter of filling in our numbers. Here, let's erase this a little better. Now it's going to our triangle, opposite over hypotenuse. Well, this was given to us, but opposite over hypotenuse of theta is negative 5 over 13. Cosine of theta here is going to be adjacent over hypotenuse. That would give us negative 12 over 13. And opposite over adjacent is negative 5 over negative 12. Negative divided by negative becomes a positive 5 over 12. Remember, one of our other trig identities says that the tangent of theta is also the sine of theta divided by cosine theta. So if you took this fraction divided by this fraction, you'd also end up with this same answer, 5 over 12. Okay, now our other three trigonometric functions are just the inverses. So hypotenuse over opposite, just flip this fraction over here. You're going to get 13 over 5. I always put the negative sign in the numerator. Negative 13 over 5 is the same as 13 over negative 5. Doesn't matter which numerator, denominator, where that negative belongs. I always put it in the numerator. Now the secant is the inverse of the cosine, which gives us a negative 13 over 12. And cotangent is adjacent over hypotenuse, which is the inverse of the tangent, which would give us a positive 12 over 5. Okay, so these 6 trig functions are not hard to put together. The key is making sure you built your triangle correctly. Special note of what quadrant your triangle is in so that you've got your signs correctly. We know third quadrant is negative, negative. And we knew this was a right triangle, so we used our Pythagorean theorem to find that third side. Hope this helps. Let me know if you have any questions. Talk to you later.